Hello, Maurieo! In this video I'm going to give you a bit of a heads up as to how you could go about doing the volume assessment. So let's go and have a look at the volume assessment itself and see if we can come to grips with what we have to do there. So here it is, and I've put a few scribblings and things on there. So this is the volume assessment exercise here. Here you have a contour plan of a section, and there is to be a dig out for a building. It's going to build a retaining wall here, here and here, hard up against the boundaries. So we just want to work out the volume of the dig out for the amount we need to dig out to put the retaining wall in. Let's not be too worried about any extra. You're not getting paid for that in this job. So we're going to dig out exactly how it is. It's very very solid clay that we're working in, so there's no need to dig any extra, just what we need. So there's going to be a retaining wall that goes along here, and along here, and here it's going to pretty much come out at ground level. Now the base of the floor, so that's the base of the floor, and then we'll pour the floor on top of that, is at RL 11.15, which you can see here's the 11 meter contour here. So you could it's going to be pretty close to ground level, or maybe a little bit of fill and stuff in front of it. So what we want to do is work out a volume. So how do we go about doing that? Well, first thing is we're just going to run three sections, one along the boundary here, one along the boundary here, and one down the guts, up the middle, halfway between the two. So that's going to give us three sections, and we're going to have to draw those up, plot in the floor level and the back retaining wall, and then work out the area of each of those sections that needs to be dug out. Then once we've got the area, we can put that into the end area volume calculation and work out the area. Now for the end area volume calculation, it's just quite simply the area of section 1 plus twice the area of section 2 in this case, and plus the area of section 3, and they're all added together, and then they're multiplied by the distance, which is the distance between the sections, divided by 2. So that's for this case. If you have more sections, it's just you would add in the middle here, this is being the start one and this being the end, plus twice each additional section that you go in there. But you can see that from the end area rule that's in the notes and what have you. So first thing we've got to do is draw the section, but before we do that, as is quite common in the business that we're in, we quite often get plans that have got dimensions on them and scales and what have you, but those plans have been printed out from a PDF format or run through the photocopier or various things. So for various reasons the scale that what we're working with is not true. So the first thing we've got to do in this job here is to work out what the scale of the plan that we're working with is. And in this case here, I just ask you just to work with this distance here to work out the scale. Don't have a look at this one. I rather suspect that this plan is more of a sketch than a plan, and that the scale in one direction is slightly different to the scale in another. So please just work with this distance here. This distance is just drawn in here to give you the distance between the sections, which you'll see that it's 10.2. so it's a bit of a, when you start getting into the distance, you'll start getting into unusual distances, but that's all good. So right, the thing to do is we've got this known distance here, is to just measure that in millimeters. So let's say it measures 121 millimeters. I'm just saying that, it could be anything. 121 millimeters. So therefore 1 millimeter is, we've got 27.590 meters. If we divide that by 121, that tells us that 1 millimeter is equal to 0.2280 meters, and as we know, that's 228 millimeters. So we could say it as a scale, an RF scale or representative fraction of 1 to 228, which is not a scale that you're going to find a scale ruler for. So there's a number of ways of dealing with this. You could load the diagram into AutoCAD and scale it up so that the distance is exactly 27.590, or you could scale it up in the photocopier to get it to a known scale, or you can just take all your measurements and multiply them by 0.228. So measure them in meters and multiply them by 0.228. So, you know, whatever you do, and just make sure that it's right and you've got the same thing, because I don't know if you work out the cost per cubic meter of removing the material, any mistake you make, too much or too little, is probably going to be in that sort of order, not to mention the frustration and that it can cause. So yes, we're going to do our 3 sections. We've worked out our scale. So then what we do is we have to plot or have a starting point on our section, possibly the front here or something like that, and then we measure along to each contour interval. So we have a base for our plot. I would suggest maybe having an RL, reference RL of 10 meters, because everything will be above that. So here's the 11 meter contour here. So wherever that distance is from the front of our thing, we scale up 1 meter to 11, and then we measure the distance along to the 12 and scale up 1 meter, or 2 meters to 12, scale it on to 13, up 3, and so on till we get through to the end, and we can create a section or a representation of the natural ground level. Then once we've done that, we can draw in a horizontal line, which I've done here in the magenta. I've drawn a horizontal line at RL 11.15, which is the base of our floor pad. So we'll that's the level that we're cutting it to, and then we'll put whatever thickness floor or whatever blinding or sand or whatever pavement we're going to use will go on to that. So we're cutting out to that RL 11.15 and up, and so that then gives us an area on the section, an area of material that we need to cut out. At the front here, you may find that you might want to go a little bit outside of the actual building area, or the floor slab. You might want to go outside of that. If you draw a line across there, that would give you the front of the floor slab. So you might want to go slightly outside that, or there might be a bit of fill at the front of it, or whatever. But anyway, so on each one you will get an area. Now we need to work out the area of those. Perhaps the easiest way, given that you've measured them, is to use the little formula for the area of a trapezium, or a triangle may occur at the front here, which is, as you know, half the base times the height. But the area of a trapezium is, you take so say for instance one of these little things here, you can work out the area of that because it's half the sum of the parallel sides, which A and B are the two parallel sides. So you add them together and halve them, and then multiply them by the distance between them, and the distance you will be scaling. So don't forget to apply your scale here, and so we can mathematically work out the area of each of the cross sections to give us the 3 areas, A1, A2 and A3, which is the area of each cross section. We can put them into the end area formula, and that will give us a volume in cubic meters. And that probably lends itself quite well to a little spreadsheet or table that you can write these things in, and there you go. You've worked out your area. Now, another thing that we could also do with this is another part of an assessment. I'll just highlight this here. So that pretty much concludes what you need to do for that volume one. I'll just highlight in blue here. I'll go with the blue. One of the follow-on sort of things from this is to work out the gradient, a gradient from contours. So we could take a point here and a point here where we've got nice even contours between those points, and just roughly at right angles. Well, it's not quite as good as I'd hoped, but draw a line. It's very difficult to draw a line on this pad straight, but draw a line between them. So you measure that and convert that to meters, and then of course this is RL 13 here, and this here RL through here is 17. So you could work out the gradient between those 2 points, just to there's various reasons why you might want to know that gradient, just to see whether it's perhaps a bit too steep for a piece of machinery or something like that. So that's also part of the assessment a little bit further on, as to how you could incorporate that assessment in using this little bit of a diagram, or this little exercise here. So that's for the gradient exercise. I'll just put that in there. That's for the gradient assessment. Okay, which is additional to this here. So yeah, just to recap on that, you do your 3 sections, work out your scale. For each section you need to draw a cross section. You can do it on the back of the sheet if you wish, and again then you work out the area of those cross sections, or the area of the piece that has to be the dig out, and then apply that into the end area to work out the volume. And the volume of course will be in, don't forget to show your volume in meters cubed. So your volume is in meters cubed, your areas will be of course in meters squared, and of course your distances and what have you here are in meters. So yeah, that's a bit of a heads up on how to do that little assessment there. If you wish and you're adventurous, you can by all means load a copy of the take the PDF and convert that to perhaps a JPEG or a TIFF, load it into some sort of CAD package and just scale it up based on this distance here only, please. Just scale it up, and you can draw the sections and everything in that CAD package if you are so inclined. Okay, let's look forward to receiving your assignments.